of minus 164 degrees centigrade. So in that case, we have two concepts. One is refrigeration, other one is air conditioning. First, what is the definition of refrigeration? Refrigeration is to remove the heat from high temperature zone and transfer it to the low temperature zone. That is the definition of refrigeration. Reducing the temperature of the low temperature zone to the high temperature zone. So that is the definition of the refrigeration. Next, principle of refrigeration. Next, come to the point, very, very important, the principle of refrigeration. Say, for example, if you keep something inside the compartment provided in the refrigerator, what will happen? The heat present in that item, which is extracted and transfer it to the surrounding. That you can say lower temperature to the higher temperature. Heat transfer of item, the temperature, that is the heat present in the item, is transferred to the lower temperature to the higher temperature. That is nothing but that is the principle of refrigeration, which satisfies the second law of thermodynamics. Second law of thermodynamics. That is, the heat transfer takes place through external work. Heat transfer takes place through external work. That is nothing but the heat to transfer takes place from lower temperature to the atmospheric temperature. Lower temperature to the atmospheric temperature. Next, come to the point, very, very important for mechanical engineers or computer science engineers or anyone. The refrigerant. What is the function of the refrigerant? So many times you may face the problem in your refrigerator. The cooling effect goes on reducing. Cooling effect goes on reducing in the refrigerator. If you ask the refrigerator mechanic, he say that the gas present in the refrigerator is less. For that reason, the cooling effect goes on decreasing. So for that, again, charge the gas in the refrigerator. They're calling it as the gas. That is not the concept. That is actually refrigerant. That is actually refrigerant. The function of the refrigerant is to extract the heat from the temperature, from the system temperature of the refrigerator and transfer it to the surrounding. Transfer it to the surrounding. That is nothing but the refrigerant is the function of the refrigerator. Refrigerant is to extract the heat continuously from the items kept inside the refrigerator and the meantime transfer the heat to the surrounding, to the atmosphere. That is nothing but the heat transfer through the refrigerant. Say, all of you observe here, the different types of refrigerants are available in the market. They are ammonia, freon, methyl, chloride, carbon dioxide. Say, in market, we use freon 12 and freon 22. Usually, freon 12 for refrigerator and freon 22 for air conditioners. That is the refrigerant used in cooling of the system. Say, all of you, once again, all of you just to write down the word refrigerant, put a hyphen, ammonia, write down one by one, ammonia, comma, next you write down freon, in bracket write down freon 12 and freon 22. Close the bracket. close the bracket. And next write down methyl chloride, comma, carbon dioxide, etc. Next, all of you observe here. This is the refrigeration concepts. That is nothing but the heat flows from higher temperature zone to the lower temperature zone. Then fluids absorbing heat. Fluids is nothing but refrigerant that is absorbs the heat from the system that is in the compartment. Next, freezing temperature depends upon the freezing temperature, and boiling temperature depends upon the type of refrigerant used and the type of external use, that is the compressor used in the refrigerator. And next, the heat flow from low temperature to the high temperature and satisfies the second law of thermodynamics. A heat transfer takes place through the external work, then this satisfies the second law of thermodynamics. Next, come to the point, very, very important. All of you write down parts of the refrigerator. Suppose if you already written this diagram, no need to write again. Just to observe the what all the parts you have in the refrigerator. What all the parts you have in the refrigerator? First, compressor. All of you observe here in the left side, you have the compressor or pump. It is connected to the condenser. The name itself condenser, which condenses the freon, that's the refrigerant. And that from the condenser, it is sent to the expansion device, where expansion of the refrigerant takes place, and then expansion to the evaporator, where evaporator evaporates the refrigerant, again which is sent to the compressor. Again the refrigerant is compressed and again sent to the condenser. This is the continuous cycle, and that is nothing but continuously extracting the heat from the compartment of the refrigerator. So once again, all of you go through the components present in the refrigerator: evaporator, condenser, circulating system, and expansion device. See, this is the explanation of evaporator, circulating system, condenser, and expansion device. Next, all of you write down refrigeration effect. All of you write down the refrigeration effect, comma, unit of refrigeration effect, comma, unit of refrigeration, and ice making capacity. Ice making capacity. Say, all of you go to the explanation, that is the refrigerating effect. That is nothing but heat absorbed in the cycle. Remember, all of you remember the heat, the rate in which the heat is absorbed in a cycle. Heat, the rate in which the heat is absorbed in a cycle from the space or compartment of the refrigerator, and cool, the system or compartment is cool. That is known as refrigerating effect. Refrigerating effect. That is the refrigeration system. See, remember, all of you write down. First, you write down refrigerating effect. Next, you write down usually the refrigeration system, that is capacity of the refrigerator or refrigeration, is called as tons of refrigeration. All of you write down tons of refrigeration. TONS, tons of refrigeration, which is the unit of refrigeration, All of you write down tons of refrigeration. the ton of refrigeration is defined as the quantity of heat absorbed. Remember, the quantity of heat absorbed in order to form 1 ton of ice. Remember, the quantity of heat absorbed in order to form 1 ton of ice in 24 hours. Say, for making of 1 ton of ice in 24 hours. In 24 hours, and the water is kept inside the chamber is at 0 degree centigrade. The tons of refrigeration is defined as the quantity of heat absorbed in order to form ton of ice, ton of ice formed in 24 hours. So if you remember, this is very, very important. Underline the words tons of refrigeration. Put a colon and hyphen. Write down. Ton of refrigeration is defined as the quantity of heat absorbed. The quantity of heat absorbed in order to form 1 ton of ice form with 1 ton of ice in 24 hours. Remember, the 1 ton of ice formed in 24 hours when the water is kept in the refrigerator is at 0 degree centigrade. Is at 0 degree centigrade. Remember, once again, the the definition of the tons of refrigerator is that is the quantity of heat absorbed in order to form 1 ton of ice in 24 hours, and the water is placed inside the refrigerator is at 0 degree centigrade. And 0 degree centigrade, that is nothing but according to American ton, that is 2000 pounds. That nothing but in India, that is 900 kgs. 1 pound equal to 4.5 kgs. For that reason, that is the ton in India. That is according to the ton of refrigerant represented by the in American ton. That's 2000 pounds. And the standard international system, 1 ton of refrigeration is equal to 210 kilojoules per minute, or equal to 3.5 kilowatts, or equal to 3.5 kilowatts. See, all of you observe here. This is very, very important. Mark it very, very important. You can expect this question in the examination. That is, define the ton of refrigeration. Ton of refrigeration. The ton of refrigeration is defined as the amount of heat or the quantity of heat absorbed in order to form 1 ton of ice in 24 hours, and the water is kept at 0 degree centigrade. This is called ton of refrigeration, and usually that's represented in American ton. American ton equal to 1 ton of American ton equal to 2000 pounds. But in case of standard international unit, that is 1 ton of refrigeration is equal to 210 kilojoules per minute, which is equal to 3.5 kilowatts. 3.5 kilowatts. This is a very, very important examination point of view. Next, come to the point, that is the ice making capacity. Ice making capacity. Ice making capacity is 2. That is the ice formed per hour. Ice formed per hour. The capacity of the refrigerating system, that is the beginning of water at room temperature, and to convert that into solid ice specified by kg per hour. That's nothing but ice making capacity. That is the capacity of the refrigerating system is to making the ice, making the solid ice, that is in kg per hour. That's the ice making capacity. All of you observe here. Ice making capacity of the refrigerator is defined as, that is the refrigerating system is to convert the water at room temperature to the solid ice, that is in kg per hour. Kg per hour. Next, come to the point. The coefficient of performance of a refrigerator or relative coefficient of performance of the refrigerator. That both are same, but the thing is COP is very, very important. So you have to calculate all the mechanical engineers. You fifth semester, you have a problem on COP of refrigerator. That is COP of refrigerator and as well as the COP of the air conditioner. Here you have to calculate the COP of the refrigeration system is nothing but the amount of heat absorbed in the system. For that, how much work is supplied to the refrigerator? That is heat absorbed or removed. That is in kilowatt. That is Q. Q is nothing but the heat absorbed or removed. That is in kilowatt. And the work supplied to the refrigerator. That is the work supplied. That's in kilowatt. Coefficient of performance equal to, all of you know that it is the ratio of input to the output. That is the input Q and the output is W. If you substitute the values in kilowatts here, you will get the coefficient of performance of the refrigerator. And the same way, the relative coefficient. See, this is the relative coefficient of performance. That is nothing but the relative coefficient of performance is the ratio of actual COP to the theoretical COP. Say you have the values, you can calculate the COP of the refrigerator by using equations, that is relative COP equal to the ratio of actual COP to the theoretical COP. Remember, in the examination, you may have this question, coefficient of performance and relative coefficient of performance. Relative coefficient of performance is nothing but that is the ratio of actual COP to the theoretical COP. Next, come to the point, the refrigerator and refrigeration. See, all of you, we already studied the refrigerator is the machine and the system is used here is the refrigeration. The refrigerator machine, so which removes the heat from the material kept or the items kept in the compartment by the external work and satisfies the second law of thermodynamics. Say, next come to the point. All of you write down types of refrigeration system. Types of refrigeration system. All of you write down types of refrigeration system. Say, write down one by one. Number one, air refrigerator. Air refrigerator. Next line write down. Number two, vapor compression refrigerator. Next line write down. Number two, vapor compression refrigerator. Next line write down. Vapor absorption refrigerator. Next line write down. Number three, vapor absorption refrigerator. And all of you observe here, you have three types of refrigerators here. The refrigerator which you have in your house, which belongs to the which system? Is it air refrigerator or vapor compression refrigerator or absorption refrigerator? Say you have a question in your mind. Remember in your lifetime, that is vapor compression refrigerator. Say whichever the refrigerator you have in your house, that belongs to vapor compression refrigerator. And very, very important thing, as per your BTU syllabus, you have only vapor compression refrigerator and vapor absorption refrigerator, and you don't have air refrigerator. Only you have two, vapor compression refrigerator and vapor absorption refrigerator. Then come to the point, vapor compression. What is the meaning of vapor? Vapor is nothing but Freon 12. That is the refrigerant used in vapor compression refrigerator. That is the Freon 12. You can call it as gas or refrigerant, which is used in the vapor compression refrigerator, where the vapor of Freon 12 is vaporized, condensed, made into liquid, again compressed, made evaporated, and again cooled, again condensed, again evaporated, again cooled. The cycle is continuous. You will learn the circulation of circulation of refrigerant in the refrigerator to remove the heat from the system. Say whichever the items kept in the refrigerator, that we call it as the compartment or cooling system, or the box which you can see in the refrigerator, that is the system or compartment or chamber. The continuously heat is removed from the items kept in the compartment by the circulation of the Freon 12. And the Freon 12 is the refrigerant which is compressed, expanded, evaporated, and again sent to the compressor, again compressed, sent to the condenser, and sent to the expansion unit, again sent to the evaporator, again which is sent to the compressor. The cycle is continuous. All of you observe here. This is the diagram of the vapor compression refrigerator. All of you observe here. Vapor compression refrigerator. So this is the refrigerator you have in your house. You have in your house. This is the vapor compression refrigerator. All of you observe the components present in the refrigerator one by one. Backside of the refrigerator, all of you observe in your house, evaporator coiled tubes. Evaporator coiled tubes that is present in the backside of the refrigerator. Next, that is the refrigerant vapor at low pressure coming in this direction. All of you observe here, come in this direction, and which is directly fed to the compressor. All of you observe here, dry refrigerant at low pressure, which is coming in this direction, which is directly fed to the compressor. On the compressor, you have a motor that is nothing but the external work. The motor runs at the RPM of 1200 RPM or more than that, which is placed in the compressor in order to compress the low pressure refrigerant. Refrigerant is nothing but Freon 12. And very, very important thing, all of you see the compressor in the refrigerator, which is hermetically sealed. Say the meaning of hermetically sealed means this is oil proof. The complete compressor is filled with oil, SAE 40 or SAE 90 oil is completely filled with the compressor. Completely filled with the compressor. And then the whichever the refrigerant with low pressure sent to the compressor, which is sent to the expansion unit. Here the what will happen due to the expansion of the compressed freon, the temperature and pressure temperature reduces and the pressure increases, which passes through the tubes present here, and flows in the direction, and this pipe is connected to the throttle valve, where the throttle valve controls the flow of refrigerant to the evaporator. That is nothing but evaporator. The front of this tubes, you have the freezing compartment. We call it as a freezer box or freezing box. In there only you are keeping the food items, keeping the food items, medicines, milk and drinks, other items in the freezing compartment. That is in the other side of this tube. This is the back side of the refrigerator. What all the components present here one by one. This is the evaporator coil. Next, from the evaporator coil, dry low pressure refrigerant is sent to the compressor, where the compressor, the function of the compressor is to compress the refrigerant and again sent to the expansion unit, where the expansion of the refrigerant takes place. Due to that, the pressure reduces, and the meantime temperature also reduces. And the pressure is very, very high, and that refrigerant is fed to the throttle valve, and the throttle valve is connected to the evaporator. Again, the cycle is continued, and the refrigerant is supplied to the compressor, expansion unit, evaporator, again compressor. The cycle repeats. Due to this, there will be continuous extraction of the heat to take place in the freezing compartment. This is the principle of operation of vapor compression refrigerator. Now I end this class and I will continue in the next class. Now I make unmute to all. If you have any. Kunal, can you listen? Kunal, can you listen? Kunal, can you listen? Kunal S. Jain. Renil. Neha, can you listen?
Yes, sir.
Do you have any question regarding the refrigeration, type of refrigerant, and the type of refrigerators?
No, sir.
Okay, thank you. Now I stop at this stage and I will continue in the next class. Thank you very much.